Guys, I just want to share with you about some topics in mathematics. And let's start the first one. So this is about vector. And normally when we start the discussion about vector, I have several points here. For example, I'll start to discuss how we get a vector from one point to another point, and then how we get the components of a vector, and then the magnitude of a vector, unit vector, and so on. So these are some important topics that we need to know related to vector. So let's start with the first one. Now, for example, we have some points on the two-dimensional space. So we have x, y axis here, and then we have now the first point. Let's call it A. This is located at 2, 1. And we have the second one, B. So let's have B at this 6, 2. And then the next one is C. And that's located at 5, 4. Now, what happens is when you have 2 points, for example, A and B here, you can have a vector coming from A to B. So that's the first vector I have here, a vector coming from A to B. Let's call it AB. So what is a vector from one point to another point? Well, we can now calculate this by just subtracting the final point minus the initial point. So B minus A. In this case, we have B minus XA at the top, and then YB minus YA. So in this case, we have now 6, and then 2 minus 2, 1. So we have now 4, 1. So that's AB. Now what if we have a vector from A to C? So we have another vector from A to C. In this case, it's just XC, YC minus XA, YA. So we have what? 5, 4 minus 2, 1. Now, when you look at these vectors AP and AC, they have the components. That's why they are vectors in two-dimensional space. So this is the first component in the horizontal direction or X direction. And this is the second component, in the Y direction or vertical direction. Now, if you have other vectors that has 3 components, for example, I have now vector U, and let's have now 1, 2, 4 for its components. Therefore, we have now a vector in 3-dimensional space. Now, let's suppose you have a vector in 2-dimensional space. So, for example, we have AB, and it is 4, 1. What does it mean? So this vector has 4 horizontal components and then 1 vertical component. So as you know, when you got AP before, the vector was like this. Well, let me just make it a bit nicer. There. So that's AB. And as you know, this vector has components. The first one is the top component is 4, which is the horizontal component. And the lower one is the vertical component. Now, if you want to get the magnitude of AB, or we can write it like this using vertical lines. Now, what you can do is just to use the Pythagoras formula, which is square root. Now, the square of horizontal component, and then plus the square of vertical component. So in this case, we have square root 16 plus 1. So square root 17. So that's the magnitude of a vector. You can simply use Pythagoras formula. What about this vector u? If you want to get the magnitude of it, the same way you can just use now square root 1 squared plus 2 squared plus 4 squared. So it is square root 1 plus 4 plus 16. That's how you calculate the magnitude of a vector. Now, the last thing that I want to discuss with you is the unit vector. What is the unit vector? It's simply a vector with the magnitude equal to 1. So that's the definition. Unit vector is a vector with a magnitude equal to 1. So, for example, unit vector u, or we can write it using a small cap like this. It is calculated as 1 over the magnitude of u times the vector u itself. So that's the formula, actually the formula of a unit vector. So when you have now that u before, what was that? 1 to 4, remember? Now you want to get the unit vector of it. What you do is just now to calculate its magnitude, which we already done, square 21. So the unit vector is 1 over that number, and then times the vector u itself, which is 1 to 4. So that's unit vector u. So this is what we learned for today, and later I'll continue with the other topic. Right, thank you.